Um, so it's been a while since I posted to YouTube, and I've produced lots of videos, but they're just hours and hours long, and I just figured it wasn't worth putting up there. So I would like to make something quickly that is consumable. This is kind of a project that's got a beginning and an end. The project we're doing right now today is we're gonna create the equivalent of the select statement. So if you don't know about the select statement, do man select and whoops, wrong one. I think it's probably man 5. Which one is it, my friends? Oh no, it's help select. It's a bash statement. All right, so select. Well, a lot of people don't know about this. It's actually really remarkable. This is how I do things like this. So I do zet. Um, I mean, like edit peg, right? Pegging. So what this does is this is a bash script, and it takes a long time because it's, and that's one of the reasons I'm doing all of this, because I'm rewriting everything in Go, which is so much faster, by the way. And so this goes out. It looks through my index for my Zet, my old one for Zettelkasten, and it finds all the entries from my thing, and then it sends those entries using a select statement like this to, um, and it does whatever's inside of the middle thing, and then it prints it out, and then I can select one, and then it will do the action. So let me show you. Like if I push 3, and it'll open up my bonsai mark and peg and go. That's funny. I need to go read this because I'm doing this right now. Anyway, and so let's actually look at the source of that select, so you can get an example of an actual select in the wild before we dive into doing it in Go. So this is in my command Z repo, but this is getting replaced, so probably nothing you want to mess with right now. But so here you go. Select Z. So select prefix in Zets. So what this does is it selects all of the Zets, and then it runs this thing and echoes the prefix. There's actually other ones that I have. Let me see. Okay, here we go. So echo blah blah blah. So these are just echoes. And by the way, so what is this good for? This is good for selecting from a number of line entries. So you send all those lines, and it'll do whatever's in here to the one that you pick. So all of the prompting and the giving it a number and all that stuff, that's all done for you automatically, and it actually will page it for you. So that's the hard part. I don't know if we'll be able to get to that today, but it is kind of cool. So like if you have, so if I do, I don't know, Zet. Let's try one that's got like a ton of stuff that I've talked about a lot. So, Golang. I don't know, Golang. No, there's only 16 of those. What's one that has more than like 25? Let's see. How about web? Nope, only 19 web entries. How about the word and? There we go. So there's 211 of those. Now, I thought it paged it. I guess it doesn't. Well, that's good. That's good. That's good to know. It means it's less coding for us. Maybe that's something that we should do, though, right? Is we want to isolate those things. So what is select doing? So select is taking a list of strings, and for each list in the string, it's printing it out, giving it a number, and then it's printing a prompt at the end, and asking you to enter, which thing that you want, right? And I actually just remember that I've already written this. I just remembered where it was. I thought I'd forgot about it, but I think I just remembered where it was. Give me a second. Yeah, it's in here already. Shh. Pretend like you don't know it's there. It's in my term. I could not remember the package it was in. It's definitely in my term package. Yes. Strip non-print, prompt hidden, prompt read hidden. I bet it's here. REPL. I'm pretty sure it's here. If it's not here, it needs to be added here. Reads a single line of input and chomps to the controller. Yes. Print is the direct. Maybe it's not. What? Okay, so it's not here. We can put it here. Okay. I could have swore I wrote this already. I could have sworn I wrote it. Maybe not. So we'll go ahead. Prompt prints to give a message. Terminal is active. Prompt hidden does another thing. Strip non-printable runes. Emphasis from less. Huh. Well, that's definitely the place we need to put it because it's a terminal thing, right? Um, huh. I wonder if it's under here. No, this is just the thing we were doing for testing. Well, okay. Well, that's good. Then you got a project. I don't have to like. But that's definitely where we need to put it. I'm glad I remember that. That's definitely the package it belongs in. I feel like I've written this already. I swear. I know I've written it somewhere. I just can't find it. Lots of examples here. See here, it pretty sure it's the REPL. So I think this is what happened. I wrote all the pieces to do this, but I didn't put them together. So the REPL. Let's go look at the REPL. Maybe the REPL has it. Let me go look. REPL. A REPL is a read evaluate print loop. Functional read evaluate print loop passing each line of prompted input to the responded function as it is entered. All right. So yeah. So this is how I mean we can actually write our function our select using all of this good stuff. Thought browsing and everything. Yeah. So read hidden. I mean, there's some good stuff in here. We're gonna go ahead and use this. I think this is the way to do it, though. We're gonna have to make a REPL, and we'll that part of it. Maybe we'll write from scratch, because at the end of the string. So watch. So like if I don't pick something, it'll just keep prompting me, right? So you kind of need a REPL. Yeah, we need a REPL. Okay, so I guess we don't have to write that part. Well, let's just start from scratch. Okay, so let's do first things first. So let's kind of like outline what's going to be needed. Now, let's definitely put it in the term package. So, if you don't know how to make a GoPro project, let me just tell you how you would do this if you're doing it from scratch, right? I'm wondering if we should go ahead and treat this as a new project so you can have the whole beginning to end kind of thing. Let's do that. Even though I know I'm going to put it into the term project. Okay. So that'll make it a better video for you because you'll get a walkthrough of everything, right? So step 1, make a GitHub repo. If you don't have a GitHub account, do it. Stop right now, pause the video, go make a GitHub account. Step 2, set up your SSH keys and everything so you can clone. If you want to, go ahead and set up your GPG keys so you have signed commits, which is great because you can't commit to certain open source projects without it. So those things are assumed that you've already done that. And then step 3, pull down your repo. Organize if you haven't got Linux going on, go watch the boost. I'm writing a book called Terminal Velocity. I'll put a plugin for that. And it will be done by May the 4th, if not earlier, of next year. And you can go get that book. You should be able to buy it on Amazon, whatever you want. And it's free, but, if you want the paper version. That is my goal by May the 4th. So if you don't know how to use the terminal and all this other stuff, you're going to have to pause and do that. But you can watch... If you know how to use Go in the terminal command line, you can go to that. You can go watch the boost videos if you haven't done that. Okay, so that's all the prereqs. I'm assuming you don't know anything about programming, and you know what? I'm assuming you know how to program in Python. Okay, I'm assuming you know how to program at least in Python or something similar. So when I refer to coding, it's not going to blow you away. But that's what you need to know to not be lost for the next 90 minutes to an hour, 2 hours. Okay, so let's go from there. We're going to make a GitHub repo. We're going to use the GH tool. I've gone through this deeply. And you like your hello world. What happened to chat? Why isn't chat showing up? We need to put chat on the screen so everyone else can laugh with the rest of us. Wait. What? Check 1, 2. Hello. Wait, where did my chat go? I feel denied, my friends. I feel like chat has been denied from my thing. I have, what? Let's turn the clock off too. Actually, no, we can. Well, I tell you what. Let's turn the clock off. I'm also gonna move my body down. I'm right here because so you can see the VI stuff on the bottom. Where is my clock? Let's turn the clock off. Where is chat? You know what? We'll leave chat. You're enjoying the silently enjoying. Yeah, where are you, people? My chat is just not loading. Oh well. I mean, there's chat. I promise there's chat happening right now. But anyway, it's probably better if I make YouTube videos without chat on. So we've got this repo. We don't have a repo. We're making a new repo. So let's make a new repo. So GH. First of all, let me see if I have one already. Clone select. This is a command that I made that goes through. If I have a clone, it like grabs it. It says, "Oh, don't have one. That's good. I don't want to make a new one if I have one already." So I got myself into my GitHub repos directory. You should definitely follow some sort of a convention with how you save your repos because you're going to have hundreds of them from different people. So get that figured out before you do this. Otherwise, just make a directory like that. And then we're not going to make a directory in here for the repo though. So GH, we're going to use the GH command. You should learn it and love it. GH repo create. And we're going to make a repo. We're going to call it select. You could call it select.go or whatever. Yeah. I'm just going to call mine select because I only code in Go these days. If I'm going to do Rust, it'll be -rust or something, but not happening. Bash select in Go. And public, would you like to make a git ignore? No. Would you like a license? Sure. Let's do Apache. Enter that. And continue repo locally, yes. All right, so now we can cd into it. We should have a select repo. And we're going to be living here, so it's time to start tmux. So we'll start tmux, and tmux is operating from this location. And so we're ready to start. So this is how do you start a Go project. You should know all this. Go mod init, and then you give it the name. RDX Rob, select. You can call yours whatever you want, but that's what I'm calling mine. You don't need the .git or anything on there. That makes you a Go mod file, right? And I mean, we could do all the other README and everything, but for right now, that's all we need. And then we need, this is going to be a package instead of a command. So we're going to go ahead and start by making a file. We're just going to touch a file, and we'll call it select.go to match the name. We're going to open up that file. And I have, vimgo set up and everything. So if you don't have that, you're going to need to take time and do that. Package, select. Okay, so this is in the select package. And then, we're good to go. So that's the minimum. We actually have a Go thing. Why do you want more? You don't need anything else. Oh, can I not name it select? That's right. Select is a keyword. Yeah. I'm going to have to name it choose instead. Yes, we are. That was good. I'm glad we hit that. Move select to choose.go. So I have to go out to GitHub and rename it. Let's go out to GitHub. GitHub.com, select RBX raw, select. Don't you love it when this stuff happens live? All right, we're going to rename this guy. Settings, select is now choose, because you can't use select as it's a reserved word, of course. All right, so back in, we're going to move select to choose. Now, we didn't actually save it yet. Wait, what did I do? Oh. Move select to choose. See to choose. Choose wisely. And I have to change our go.mod because we changed the name. If you want to use Go 1.19, you can. I'm using 1.18. And, all right, so we have the beginning of a thing. So that's actually, so let's do a README and then we'll go ahead and commit it, our first commit. We could say bash select and go. Yeah. Yeah, we can just say is key word. Yeah, there we go. I could put a little italics here. A note. Note that select is a keyword and go. Get origin. Not yet. I don't need to because I haven't pushed it. I haven't. Yeah. I don't have. I mean, I could change. Yeah, let's do that. I guess it did make the origin automatically, didn't it? I didn't know if that. Yeah. Choose fetch remotes origin. How's it going, John? So remote origin branch main blah 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 blah. All right, so let's go ahead and save our first stuff. Let's make sure it works. So go test. No test files. Well, there's no test files. So I mean, it's a good first directory. Let's go ahead and add it. So git add dash a dot git commit add initial files. Git push dash u origin main. There we go. Hey, how's it going? So I wish we could put your chat on the screen, but oh well, everybody, we're not going to have that for right now. I mean, we're doing YouTube videos, so I should probably keep chat off the screen. Good morning, Annie. All right, so we've got a brand new project, a brand new Go project. It's called Shoes. It doesn't do anything, and it has been saved to the GitHub. So bash select and go. Right, so we're ready to start doing our development. Was that commit verified? Let me check. Where's my commit? What? Verified. Yay. That's because I got GPG set up finally. So I am a verified committer. And we can go do this. All right. So again, what are we trying to do? We're trying to make bash select and go. So if you don't know what that is, you're going to have to look at it. So let's start by writing. Now, the hard part of this, and this is something I have a lot of difficulty when I'm doing Go development. Because Go, by default, I mean, how do you test an interactive terminal application, right? Without going to extreme lengths to mock up a user sitting at their terminal. You can do it, right? You can do it. There's some pretty cool tricks you can do using the binary and sending a standard input and watching a standard output and stuff like that. But on the whole, you kind of have to decide if I want to spend a lot of time doing that or if I just want to make a command and run it interactively as a user and test it that way. And that's much faster, and I found myself doing that a lot. And that's, by the way, don't let any CI/CD or test-driven Nazi tell you that that's less than the actual need of testing because you didn't get coverage because, oh no, you did it by actually making a program instead of using some dumbass unit test. So I'll put that round aside for a bit, but what I'm trying to tell you is that rather than making a choose_test file, which I will make in order to test the individual pieces as much as I can, I know right away that I'm going to need a command, right? That in order to test this, I'm going to need a command that's going to prompt me, it's going to give me an interactive session, right? And I'm going to be able to need to run that, compile it, and test it. So right away, I know I need a binary in this package if I want to do it. So for that, use the convention to name a command. You do put it under the command directory. This is a pretty standard convention followed by the community. And under there, we're going to need to make the name of our command. So I'm just going to make the name of the command choose. So we'll say make directory command choose. And now inside of that, we'll need a main directory, a main file, main.go file, right? And we'll just keep this one here. We could say, would run choose. And this is gonna serve as an example, as a sample, as well as potentially do a lot more for us. I mean, there's lots of ways we could do this. We could put a test directory and go ahead and do that without that. You do need to have tests in place, but not like this is a test, is what I'm trying to tell you. I did not say coding without tests. I said a compiled program that runs your code that's run by a human constitutes a test. Okay? I didn't say don't test your code. That's not what I said. I said not having a unit test that's automated is okay. I know people are going to yell at you. They're going to say, no, you're less than human for actually running a program as a human being and testing it. The opposite is true. In fact, you need to do that more. Our world is plagued by people who obsess about unit tests that are completely useless. The SolarWinds hack happened because of that. If there had been a human involved with the code-based testing instead of this stupid ass CI/CD, it would have been caught. So there. Okay. I'm gonna go for this. So would choose to run. All right, so in order to install this, so you might think, well, okay, well, how do I build that, right? Well, as long as you don't care if choose is installed in your system in your binary path, and I don't, then you can just do this. You can say go install dot slash, gotta have the dot, cmd choose, and that'll put the choose program into your thing, and now you have a runnable program, right? So now this program can use whatever it is that we're writing over here. So we're gonna do choose.go. Now, what is it that our thing needs to do? Well, we want it to take take a list of strings, and we want it to print out those strings, right? So we can actually mock that in our choose program. So let's pretend like we're using it in our application here. This is again that constitutes our test. So let's go ahead and write it in here instead of in a unit test. And we're going to say, so let's say we're just going to guess up an events here. Hey, pardon, let's do var choices. And I mean, again, this is a simulation, so, and we're going to make some choices. So choices, I mean, what do we want to call them? First choice, second, third, fourth. Second, third, fourth choice. Again, we want to be able to pass these in. I mean, maybe we'll make it something more useful there. You could actually make it into like a little miniature version of I mean, we could actually turn choose into a bonsai tree, but I don't know. We'll see. Anyway, so what do we want it to do? We want it to print out a prompt for all of these things, right? And so we're going to do this. We're going to say never executed, right? Yeah. Well, it depends on how you set it up. If it has package main, then it's considered a command. If it's package anything else, then it's considered an importable package. And you can't mix the two, obviously. So we're going to do this. We're going to say, I want this program to run. So what do I want to do? I want to run it. So let's say this. Let's do choice. I mean, we're kind of scaffolding out our thing. Let's say my pick equals we'll say did I say choose? Yeah, choose. And then so this is kind of fun because now we're kind of like figuring out, because our package is named choose, so it already has a verb in it, so we can do this thing where we don't stutter, right? So we can say choose dot what? Choose dot we could say from. How about that? Choose one, choose multi. No, we're going to say choose from, and we're going to use an array. Now, right now it's an array of strings, right? You know what's really cool? You want to make it? Should we make it a generic right away? Should we use the generics? Let's do that. Let's use generics. So it's a string, but it doesn't have to be a string. All right. So let's say choose from type string. In fact, we probably don't even need to put type string because it can probably be implied. Yeah, let's do string though. I want to make it a generic so you can see how to use generics. Pretty cool. Why would you use a generic? Because maybe you want to have an array of stuff that's not a string, but you want to show them the string representation of the thing and then pick that one, which is super cool. And that actually lets me show you a bunch of cool things about Go. So let's do this. Let's say pick choose from choices. All right. And that's what we want. And then we're just going to print the pick out. Now it's my Go is like freaking out because it can't find anything. It's like looking all over for it because it doesn't exist yet. So let's do that. And then let's do fmt println pick. So that's all we really want to do. It's a pretty basic thing, right? But we're going to get a lot of things here. We're going to be able to do some terminal color and all kinds of stuff. Take that guy, put this here. Alrighty. Okay, so this looks done. I mean, that's we don't need much more than that, right? We will be trying out some different choices here later, right? And we're going to use the generic, and I'm going to show you why the generic's going to be cool later. All right, so let's do that. So now we know what we're making, right? So, so let's do that. So func from, we need a from, of course, and we need to take in something. Well, right now, from choices string, you can get verbose on that if you want. You don't have to. And then we're going to return a string. All right, now how do we turn this into a generic? So, and let's put a little thing in here from prompts user terminal user to pick from one of the choices. All right, so we've got a little document there. Let's go ahead and return an empty string. And this is interesting because what if the empty string, what if one of the possibilities is an empty string? Should we make it so there's no such thing as an empty string possibility? Hell no, actually. We probably need to return an error, right? Because we don't know what type of thing it is we're going to be returning. So that we probably need to do a double return on this. And this is a pretty idiomatic go to do this, right? So because it's possible that it's an empty string, particularly when we start doing generics, because then what is the empty value? As soon as you start getting specific in the empty values, then you lose the ability to make a generic. So let's do that. We got a to do here. And we need to change our signature. So let's go back in here. And we have a pick and an error. And then we just need to dump our if error, do something here. If error, in this case, we won't return the error. We're going to say log. Always log errors. Can I say it again? Always log errors. Do not print your errors. Log your errors. How would you print hello if it's pick as an empty string? Exactly. That's what I'm trying to say. So now we have an error. So we're going to check the error. It's very common to return 2 values from Go, which keeps you from chaining and stuff, but that's not a problem. Chaining is actually almost not idiomatic Go. It just depends on some things do it, but it's very rare. So let's do that. Let's say log. Why am I logging instead of printing my error? Anybody? All right. It's one of the biggest pet peeves of mine. When people print their errors instead of logging them. It's this huge pet peeve of mine. It happens all the time. It's in tons of production software. You can't redirect standard error. Because why? Because they wrote all their errors to fucking print standard out. If you do that, you should be fired. It's kind of a joke, but not really. Yeah, I just never mix standard error and standard out. They have a purpose. Somebody engineered that shit like in the 70s for a reason. Know what the reason is and use the reason. Okay. Breathe. All right. So we're printing and we're logging. We're logging the error and we're printing that, right? By the way, we have to return early if we're going to do this. Now, instead of returning though, we're going to do something different. We're going to do an os.exit instead, right? Why are we exiting? Because we want to exit with a negative, with a non-zero value, right? So we want the program to be a proper Unix program, and non-zero values means there was something went wrong, it didn't work, right? So you picked some stupid thing, which, by the way, it shouldn't have let you do in the first place, right? So if there's an error and we don't know why the error is, then you should be there. You should not get an error, however, if you didn't pick. It should infinitely loop until you pick something, right? So that, or you Control C to interrupt it, which is another reason not to use Control C for editing commands. People do that in VI all the time. It's totally stupid. All right. So, okay. So let's see here. We're going to do, so there's our program. We got our program. We can't compile our program yet because actually maybe we can. Let's see. It's like kind of a good thing to keep your code compilable, even if it's not really doing anything. So let's do that. Let's do log print. Hey, thank you for the fall. We could do log print. We could say would prompt for choice. All right, so this is actually a working program. It's just not doing anything, right? So where's my install? Install, command choose. Would prompt for choice. Yay! And of course, it wasn't an error. See how I printed an empty line there? That's because it thinks we're okay, right? Why? Because we returned an empty thing, right? Now, if we return a nil, let's try that. Yeah, let's try that. Let's return a new error. Let's try to fmt dot error f. Easiest way to make an error. Not really an error, but okay. So if we do that, let's build that. You can tell I'm getting kind of a, we're going to automate this. Don't you worry. So not really an error, but okay. So that way it didn't print that blank line. It's doing, we tested the error handling. Everything's working, right? So there, we can turn that one off. Now it's time to get to the business of things. Okay. So what if we don't want to have it just be a string? What if we want it to be anything? Right? Well, we're going to get there. I promise. We're going to come back to it and we're going to change it into generic later. So stay tuned. So the first thing is, so we're going to go ahead and come back here and we're going to put, first of all, we need to know what we're dealing with, right? So we can just log print that just to check our variables, right? You don't even really need an L, but the log is kind of, printing is kind of like a dump. So let's see if we get choices. Let's see what happens here. Let's see, does that build and run? Missing return. Oh my God. Well, we got to fix that. Okay, we'll return a nil there. All right, so, first choice, second choice, third choice. You see what it did? It dumped it in the normal routine. So what I'm trying to show you here is that everything has a natural string version for printing. That's a Go thing. And we can take advantage of that to do things with generics later to print other types. But for right now, we're choosing from among things that are not strings. Like say you wanted to have a list of integers, right? But you wanted to show them as a string, but you still wanted the integer. It's using a stringer. Yep, FMT stringer interface. That's what they're doing. And we can use anything that has a stringer interface, but everything has a stringer by default. Everything. It'll try really hard, right? Now, so that printed the whole thing. Now, if I wanted to, I could loop through that. So, 4K and range choices. So actually, the value, so we can print V. If we wanted to print them out nicer like that, we could just do like this. String. No, he meant stringer. He meant stringer. Stringer is the name of the interface. Yeah, for things that implement string. So that's actually a thing. So first choice, second choice, third choice. You see how I printed them all out? Okay, so that's what I wanted to show you. Now let me just for giggles and grins here. I mean, this is kind of cool. So let me show you this. What if we change this so that it's any type? We want it to be any type. We don't care. This is a generic. What I am doing right now is a generic. If you've never done generics before, that's all it is. You take the type and you say, the type is now a parameter, right? And its code is going to break. It's going to be like, I don't know what to do. All the type parameters have to be named. Oh no. Okay. So down here, as soon as you do that, you just broke it, right? So we can't just go through choices anymore. Now we have to go through choices of type T, right? I'm pretty sure. Line 8 from, oh, wait. I need to put, what type it is here. Yeah. Oh no, that's not true. I think I need to have like all the different types. Yeah. Let's say that we can take, actually, no. This is probably better to do as an any. Yeah. I don't even need generics here. I just realized I don't need generics. I don't need them at all. No, I can use the any type. I don't need generics. Yep. So that's all I need. And that's one of the reasons people complain about generics. As soon as I did it out, I realized it anyway. So, but watch, now it'll do the right thing. It's still printed as a string. Type string of type any. Oh wait, whoops. Yes I can, I promise. variable type string. Can it use choices type string? I'm pretty sure I can. I type any in argument to choices from. Yes, I can. What am I missing, my friends? So I think I might. Maybe I just still need the generic. I don't know. This is good process for me to see. Good for you to see me flounder a little bit. String. Huh. Harumph. Maybe I do need to use it as a... I think I might... I think I actually might need a generic here, actually. Yeah. So... Yeah, I think it might need a generic here. For the any... because I want to be able to pass literally any an array of anything, and that... In order to do that, I have to cast it, I think. It's either that or I might be able to get away with casting it. So, but I don't want to cast it. So, you know, I mean, there's a couple ways to do this. So, cannot convert choices variable type string type any, because it's going the opposite direction, right? Huh. I know. I think I am going to have to use a generic, unfortunately. Yep. I am. And then the T here can be any number of things, though. I could put T any, but I think that I'm going to have to do... actually, I probably won't need that here because it'll probably infer it. I think we're probably going to need it on the other side. This is good. This is good practice for me. I mean, I wrote a whole map filter reduce library in generic, so I need to practice some more. So this T, I think it's because it's a string. I think it's because it's an array. I think that's why we need it. And any is one of the options. So if this doesn't like it, I know how to get around it. So choices, the rest of that stuff should work. Let's try. Cannot use a untyped string constant as T value in return statement. Oh, on 15. All right. So we need to return the value, not a string, right? Yeah, we need to if it's not here, we need to return an empty value of whatever T is. Here's a trick on generics you have to do. You have to do empty of type T, and then you can return an empty. That is a trick for generics because you don't know what the zero value is of the type, right? Oh, that worked. Nice. Okay. So you don't know what type that is, right? So I guess I did need a generic there because it was a collection of things. So, okay, but let me show you why that's matter. At the option parser for the conc commander, I don't even know what that is, but so if you go over here, let's go back to our other thing. So I'm trying to show you the power of generics. So, and of course I was a big generic skeptic for a long time. I was like, why do we need it? We don't need it. So we could say over here we could say string choices, and here we could say int choices, right? And we could just say, 1 40 234 32 or something, right? And generic options parser, nice. No Rust stream, no. No, I mean I don't have any need for Rust right now. I probably won't ever have a need for Rust. I just don't. I mean, everything I want to do, I can do with Go or Python or something. There's people who need it, but not me. So untyped int constant as a string. Whoa, I can't use ints as a string. Damn. What was I doing? I need to change this to int, right? What I change my mind about generics? If you want to see why, go look at my entire functional programming library with node trees that are generic. So let me just show you really quick. So if you go to structs, my structs repo is full of this stuff, right? And I reuse these things all the time. I don't always necessarily import structs directly, but I reuse these data structures all the time. And these structures that are in here would not be possible without generics, not at all. They're just not physically possible in Go without it, because what we're building is we're building a tree of specific type. If I were going to try to do this without Go, I would have to rewrite all of this code with hard-coded types in all of it. That is the reason. So, for example, if I want to create a node, if you know about graph structures, right? So if I wanted to create a node on a graph tree, rooted or whatever, then I'd have to have, so I can have the type, that's an int on purpose, right? But if I wanted it to encapsulate an integer or a string or some struct that I made, so I want to make a node tree and I want all of the types to be consistent, or I want those types to be any. I want to make a node tree where the value of the type can be anything. Then I would put in any as t, like I just did for the array thing. But if I wanted to all be integers consistently, if I wanted to all be strings, I put string. And then it gets implemented across the board that way. If you want to make a linked list of specific types, have to do that too. That's what a queue stack is. So that's what my queue stack is, kind of a queue and a stack combined. It's got push pop and all that jazz. And here you have, this is, the fields is specifically a string, but you can define your queue stack however you want. And so you can have a linked list or a stack of things. Right now, in this case, I made this item an any, but you could equally change out any to be something else if you wanted to. So in fact, I should probably change any to be able to be a thing. So that's why you just can't do those things without generics, period. And that includes like map, filter, reduce, and all those things. They all lose their value when you can't have them operating on a slice of different types, right? I mean, you can still use any, but there are things that you can't do. You'd have to do type switching and stuff like that, which is really a lot of overhead. No, the empty interface isn't called an empty interface anymore. It's called the any type now. That's what any is. Any is an alias for empty interface. The interface is not a type, right? Interface is a different type from an empty interface. It's super important that you know that. And that's why they got rid of it. Now they call it any. So we're going to go ahead and here we got main. So we got our choices and we can have, what I'm trying to show you is that I can change choices to int choices and I don't lose anything. It should be just fine. See that? Now why? Why was it just fine with integers? Because everything has a printable version, and integers, if you print them as strings, they work. So I didn't have to change my code at all to get this. I didn't have to change my code at all to swap out a different type. Right? I didn't even have to do a type switch. I want you to notice that. Notice how I did not have to do a type switch. Right? Now, if you know about empty interface types or any types, you would have had to have done a type switch here in order to get it to print the other way or something. Yeah. So, is detected. Yes. Println, log, all of them, they detect the string interface. That's exactly what they do. So there we go. So we have an MTT, and we're good to go. Okay. So what I was trying, so now we have our generic set up. And we can pick from any list of types whatsoever that can be represented by a string, which is pretty much every type. And I mean, it could be anything. I can make, look, let's do structs. Let's do a struct. Wait, where's my main? I know I should have two windows open. I know, I can hear you saying it. I can hear you saying it. I know. Wait, what? Why am I here? That's a good question, right, Rob? I should be in the select thing. Tmux. Oh, wait, what? Because it doesn't exist anymore, that's why. That's why. Got very confused. Tmux got confused. Like, I don't know. Main. VI, CMD. All right, so we have a main up. And now we're going to go to... make a new one here. We got choose. Let's Let's have this one be in the choose code. All right, so here we are. So we have main over here, and let's actually make a Go entry that runs the code every time. Well, no, because it's going to be prompting, so we won't be able to do that, unfortunately. So yeah. Okay, the lowercase println is different. Yeah, they're two different ones. All right, so what I was going to try to show you is that you can actually have a different struct. So let's say type entry struct equals name. Make a name a string val. So it's kind of like a map, but not really, right? So we could say value is I don't know, a float 32. How about that? And so now we have an entry, right? So now we need to make a list of entries. So var entry choices entry, and then we need we can make a different entity here. So let's do the first one is name Rob, I guess. And then what? Then we'll have value. Okay, I'm gonna need some brackets braces around that. Yeah. I mean, it's a little bit hard to do it this way, but I'll do it this way. What am I missing? I'm missing something. It might be easier to add individual entries, actually. I'm trying to do the inline method, which is, fine, but God damn it. My Go is really sloppy here. My inline defining. 25. What am I doing wrong? I have too many of these. It's not a map of entries. Oh, it's just an array of entries. Hello. Okay, I feel kind of stupid. Yes, I need to make, value equals come on, Rob. Oh, no. Do I really have to do that? I hope I don't. I think I do. No, there's a shorthand for this and I don't know it because, you know what? I don't have a fucking equal sign. Oh my God, Rob. Seriously, Robert. You forgot the equal sign assignment this whole entire time. I'm very disappointed in you, Robert. I'm very disappointed. Okay, so this is going to need a comment out. And that's what I was talking about. All right, so Rob, Doris, look at Max. He just bought a new car last night. All right, so it's compiling now, right? So let's do from entry choices. All right. Remember I said about the string version of a thing? So now it's got a string, right? Now, what if we wanted to do this instead? I'm getting distracted, I know, but this is kind of on purpose because there's a lesson to be had here. So let's say that entry choices, we don't like that. It's kind of ugly. What if we want to use JSON instead of Go as default? Well, let's implement stringer. You weren't planning on getting a stringer lesson, were you? But we're going to give it to you anyway. So we have E entry, no pointer. It's important you don't have a pointer. String, string. And if you implement this, it's called the FMT string implements fmt.stringer interface and return, whatever, right? So we're going to make a string. And what we're going to make as JSON. So let's do that. So let's say, so first of all, we need to make it. So we have this entry here, right? But we need to turn it into JSON. Well, thank God we can do that automatically. So we're going to do JSON tags. I'll call this one name. And if the name is empty, do we want it to appear? Yes, I guess we do. But if the value is empty, we really don't care if it appears or not. Omit empty. And we don't care. Right, but if the other one's not there, we don't want it. So then we need to turn it into a string. So we need a byte buffer and an error out of this. And we do json.marshal, which I hate, but there's like so many problems with. Actually, if you know what, let's do this right, okay? Let's do this right. Let's actually make an encoder. When you do this, let me show you why. This makes me so angry. I'm gonna get angry on you. Yeah. What if you have like this, all right? Max's username is something fancy. How about that? Let's try that. Well, let me show you why this is a problem. So I promise we're going to get to the select part, but I just want to show you this. So if we do this and wait, you know what we should do? We should have one that's like just for running it. Go install. All right. So we have a problem. Why are we not returning? What's wrong? Did I do something wrong? Entry choices. What did I do wrong? By declare not use. Oh, whoopsie. Did I not save it? Okay, there we go. So, do you see? Oh wait, you're not going to get to see this yet. Okay, I'm going to show you right now. So we're implementing a string in JSON. So we're going to use the general JSON marshaling, which is usually okay, right? And so if there's an error, by the way, so if there's an error, it's not equal nil, right? We're gonna cheat and we're gonna return the word null. Because why? Because null is a valid JSON value for there being an error. We also want to let people see the error. So what are we doing? We're not printing it. We're logging it. Println error. All right. So we're going to print that error, and otherwise we're going to convert those bytes into a string. Oops. This is a byte slice. Byte slice is compatible with a string. So now when we run this, we get, what's going on? What do I have going on here? Don't put errors, log them. Yes. Thank you for that. So none of arguments in call. You know why? Because you can redirect log. You can't redirect FMT easily. Log is designed to be moved to a log and stuff like that. So yeah, none of arguments are called to JSON.marshal. Marshall, Will, and Holly on a routine X, but nobody ever knows that when I sing it. To the greatest earthquake ever known. If you know that, please leave a comment below. All right, so it said name and then something. All right, it converted the A, no problem. But let's see what else we can do here. Let's see if Max got fancy with his name here. So he uses angle brackets. Okay. All right, now I try it. Spaghetti-O. So even though angle brackets are valid JSON values, I just want to tell you, I have to sigh, because that is one of my most annoying things about. I have a huge complaint to log. They changed the default JSON marshal. So unfortunately, you have to get around that. And let me show you how. In fact, I have it here. The code is here somewhere. Where is my code for this? Is it in Pagan? I think it's in Pagan. I can't remember. You have to create your own encoder. It's a pain in the keister. But you can do it. JSON s.marshal JSON. Oh, here we go. Here we go. All right. So this is what you have to do. You have to make an encoder, turn the escapes off, and then do it. Right? And by the way, it's usually better to implement marshal JSON than it is to implement string. Because guess what? String calls marshal JSON if there's a JSON thing there, right? The other thing about this too is if somebody wants to have your code be in, usually when they want to see your code as JSON, I mean, we're just kind of piggybacking. So I know this is growing into a bigger project than you wanted, right? So marshal JSON is really the one you want to implement, and then you just want to call that one. And there's actually marshal binary and marshal text, and there's like a chain, but this is really the only one that you need. So we're going to say, so this is JSON.marshaler. Some people may not even know that exists. So we're going to actually cheat. I'm going to steal the code from right here. 2, 3, 4, 5. All right, and we're going to implement a JSON marshaler here. So we make a new encoder, unfortunately, and we're going to encode ourself. We're going to set the HTML escapes to false because we don't want those stupid things. We're going to call it marshal JSON, and we're going to go ahead and encode it and see if we get an error. If we get an error, we're going to make a bytes buffer. Oh, this, you know why it does this? Because this stupid JSON encoder decides to add an extraneous line return to the end of everything. Oh, I hate that. It makes me so mad. Oh my God. It's so totally horrible. Guys, whoever implemented JSON encode and that whole thing, you totally failed. It is such a fail. I'm sorry. It is. It's a fail. So, but now you know how to get around it because you watched Art of Bix Rob. So down here, we don't need to do any of this stuff anymore. Now what can we do? Now we can cheat. We can cheat, my friends. Is it return or a new line? It's a new line. Read about it. It's like so stupid. It's so stupid. I'm going to show it to you right now. I don't know why. I'm going to show it to you right here. There it goes. Here it is. Encode, right? Okay, so number one, you have to make your own encoder if you don't want the stupid unnecessary value escaping. Number two, which is the stupid number one. Stupid number two is if you use the encoder, you are forced to get a line return. Right? You're forced to get a line return. Encode writes the JSON encoding of a V to the stream, followed by a new line character for no reason. For no reason. I mean, it's just for no reason. It just makes me so mad. Okay, I'm done. All right, so yeah, I can't even like. All right, so if we have an error, I'm going to do my little trick that I did above here. So I'm going to say, if error equals nil, does not equal nil, return null. Okay, because that means we weren't able to get anything. Null is a valid JSON value, by the way. Okay, a null string is a valid JSON value. So that helps us do our error handling, right? And oh, actually, I take that back. I take it all back. We need to put that in the string. Yeah. We need to put that in the string. In the stringer interface. We are going to have to put something here. I forgot. Because, here's why. Because this marshal JSON is kind of a different thing. It needs to get a byte slice. It needs to return a byte slice and an error. So, that's why. Right? And we probably shouldn't do this because it might not be there. So, we're going to return Yeah, I have a bug in my other code. I got to remember that. Yeah, this is a bug because this will get a null pointer error if I do that. So because it won't be there. So if what I need to do is I need to do this. I need to say if there's an error, return nil comma error. Otherwise, that'd be a over. That would be a byte panic. So I'm glad I found that. Thank you for being patient. So that just works. It's just shift. It's just over anything. You just do shift. What is that? I don't even know. K, shift HJK, shift K on any language at all. And I don't want it popping up all the time. I just want to look it up. Shift K. There you go. So, or you can just do GoDoc and go get it, right? So, anyway, set HTML escape to false, encode bytes, blah, 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 blah. So then we have, so there's a string. So if it's a null, return null. Otherwise, so this says, so then we can say byte error. I guess we still have to do the same thing. Yeah, but now we can just do Marshall encode. Marshall, Will, and Holly. Marshall JSON, right? And then we can return string byte. Yeah. Do 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 do. All right. So, yeah. I guess I could turn my other annoying things. You know what? I should do that. Let me do that. Let me turn Karnak on for you. Yeah, I need to move it over though. Let's move it over. Yeah, I'll move it over to the far side. I've been meaning to do this anyway. Yeah, Karnak is like a Windowsy thing. I am on Windows. I know the Linux purists get mad at me for using Windows to do Linux development. I'm like, bite me. I don't care. It's faster. Save. But yeah, so here we go. Now you can just watch this over here. It's a good reason not to have chat on too, so now you can just watch, okay? Anyway, so what are we doing? We got string on over here. Okay, so we're done. We got our encoding done. Now, that was a lot. You were not planning on that. But by doing that, we literally now have a JSON representation of any potential choice type. That's why we did all that. Right? Exactly. So, so there we go. Now, it's still screwed up though, isn't it? Look at this. See that? That looks screwed up to me. Oh, you know why? Because it didn't compile. It did not compile. Entry does not implement IO writer, missing the write method. Cannot use E variable type entry as type IO writer in argument to JSON new encoder. All right, well, we have a problem, so we will figure that out, what that problem is. We're editing the wrong thing here, Robert. So no, we're not. Okay, anyway. Yeah, I don't know why we put all these things in here in our sample, but entry, string, byte, Marshall, JSON. Oh, you know what? It's a... No, it's not. It's not. It should be fine. Because they're false if encode number N. Oh, this is E. That is E. I missed that. I cut and pasted that from someplace else. We also forgot our error thing. We got to do that. We don't want that null, because otherwise this will read off the end. So we want a nil and an error. I'm just saving it to reformat. That should be happier. Let's see. No, not so much. Mainline 28. What am I still missing? New encoder E. Enc equals JSON new encoder E. Does Marshall JSON need to be a pointer? I don't think it does. IO writer. Variable to entry as type IO writer and argument to JSON new encoder. Do I need to make a buffer encoder for this? I think I do. Oh my god. I hate this. This is just because of the JSON crap. Yeah, this is. I have to make a bytes buffer just to. Oh my god. Oh my god. Oh my god. I forgot the bytes buffer because I need an IR writer. So stupid. This is so stupid. But you have to do it. Now you know how to do it. And I don't. I have to look it up every time. New bytes buffer. And so because the encoder needs something to write to. So now it has something to write to. It should be happier. Yeah. It should be happier. I'm not saying it is. And now it's taking forever. Why is it taking forever? That doesn't make me happy. Is it trying to read from something? It should not take that long. Is my computer going to die? My code's compiling. Into? No, it's not. Yeah, no. Every time you're going to say, oh, it's easier in Rust, you have to like do the whole program. You can't just like throw one thing out there. Yeah. But this JSON thing is crap. Yeah. It helps that Rust was made by web script kiddies. That worked at Mozilla. It's a joke. It's a joke. God, you guys are going to fucking lynch me for saying that. Bytes buffer, yeah. It's a bytes buffer. Maybe the bytes buffer is not a thing. Did I have it wrong? Encode E to the bytes buffer. I have something wrong. I don't know what's wrong. Let me go figure out what's wrong. I don't think so. No, that's I'm not paying attention though. I have Twitch brain. I have Twitch brain right now, and I have objective evidence that I'm a better coder when I'm not Twitch streaming. And it's funny because other streamers and I laugh about that all the time. Number one, I'm talking, which is, always bad. And I'm trying to get this down. All right, so buffer, new bytes buffer. No, we're making a new reference to a bytes buffer. And I mean, this should be fine. N error equals nil. Yeah, we have some sort of recursive loop going on here. Yeah, I think we do. Yep, that's definitely a loop recursion. So there's something going on with this. Yeah. I think the reason is because we have a JSON marshal already on it. Training for the Alps. But yeah, I have a loop someplace. And I honestly don't know where it is, so I'm gonna go find it. JSON node. So the reason this one works is because I made a new copy of this one, and then I just encoded that one. And down here I call it s.marshal JSON, which should have been. Did I not put stuff on that one? Please tell me the strings that I put marshal JSON. Yeah, okay. Marshal JSON, that should have been fine. It's got a recursive loop. So what it's doing is it's encoding, and then it's trying to encode the encoding. And I don't know why. Because I'm using the stupid encoder, which I almost never use, but I'm trying to get used to doing because of the stupid HTML escape problem. Encode. Yeah, I think it's getting recursively called. No error. Buff.bytes. Oh, live coding will make sure you make mistakes. I don't know where it is. There's some recursion going on though, and I have no idea where it is right now. It's like it's calling marshal JSON on itself. It should not be. I'm probably going to have to call marshal JSON not on itself, but I'm going to have to call JSON.marshal. Yeah. Yeah, I think that's what I have to do. And then I have to pass it myself. Because I think that's what's causing the recursion. I'm pretty sure. And that's going to be something we look at here. Let me try. Let's see. Oh, nope, that's going to blow up again. Yep. It's going to blow up. That's a recursive loop. And have I said how much I hate using JSON encode? I have my own library. I have 2 of my own libraries for dealing with this that I could have just used here instead of rewriting this. But I thought, oh, I'll show everybody about the problems with JSON encode. Because this is a pain in the butt. So I've codified it to not use it. I wrote my own marshaler, actually, so I don't even have to do this shit. I could do as JSON here, and I think I might actually just do that. So yeah, if rdbxrob/JSON if you want to get deep into this. So yeah, bash aliases are stupid, and because they can't be called from an exe system call. I rest my case. So forget about calling any of them from any other program. It's marshals JSON implements JSON marshalers JSON. What am I missing? So we got a bytes buffer. We got a new encoder. We encode ourself here. This is where the recursion is happening. So I think that we actually have to make a copy of a temporary copy of myself in order to have it be encoded, but I don't remember. I'm going to go look. JSON.marshal without HTML escaping. Because I just want this done. I want to get back to the select stuff. How to stop it from escaping. Before marshal, JSON marshal the message. After marshal string, yeah. Look at that. Look at how ugly this is. Ugh, so bad. Marshal, as we go 1.7, you can do this with JSON.marshal. It's the source code for JSON marshal is blah. What? You can pass ops? Wait. You can pass options to it now? When was this? I missed this. When was this? Oh, we got to look that up. mgodoc. You can't pass something else to that. No, that's like such bullshit. Of course, that's good old Stack Exchange bullshit. It's not true. It's totally not true. You cannot even do it by a custom function. You have to use something that does not satisfy JSON marshal interface. So the workaround to write your function is this. You have to write a JSON thing that makes a byte. Oh, see what I did? Encode T. Oh, look at it's a pointer. This was a pointer. I wonder if I just change it to a pointer if that will do it, or if I'm going to have to fulfill the thing. Are you telling me I can't even use the JSON marshal interface? This is so stupid. This is so stupid. Encode calls marshal JSON. Yeah. And my other one didn't catch it because it makes a new object out of it. Yep. And I don't even think making a pointer would fix it. I don't know. That's not going to fix it. I just want to see. I doubt it. Yeah. Wait, where are we? Oh, that worked. Shit. You can't. You got to be kidding me. This entire problem, this whole problem was just because I had a stupid ass. Oh, I feel so stupid. You know why? Because it made a new copy of it every time. Yeah. That is exactly why. It made a copy of it every time. So, moral of the story is this. Take note. Take note of this. Marshal JSON is a pointer, and string is not a pointer. And if you do string as a pointer, you'll get screwed up. I noticed that. So that's important, because the reason it was recursing is because it was like making a new one every time instead of changing the one that was already there. So, and so it was probably the reflection is probably looking at for the same pointer reference, and it's like, oh, I already got this one, and then it just kept making a new one. I mean, am I wrong? It's not even doing it now, though. Oh, it's not even doing it. That's why. No. The reason it's working is because I broke it. It's not even working. It's not working because, okay, I was wrong again. And that's, of course, Stack Exchange was wrong. Like, what else is fucking new? I'm so tired of saying. So, the reason it's working is because it's not calling it. Look, see this? That would be correct if it was properly doing it. It's not. So, we're going to call this JSON. And we're going to call this... There's a way to get around this. I absolutely know there's a way to get around this. I know there's a way around this. I've done it. It's not working right now. I mean, if I do this, it's, you know, this is neither here nor there. This is not do it. This is like, you know, JSON, encode buffer, encode E, and then return bytes buffer. Okay, so let's see. I mean, this will work, but this fix is not the fix. The reason this is not a fix is because you want it to do the JSON properly anywhere it does JSON, not just here. So this is not a proper fix. We were not planning on going down this rabbit hole, but this is super important. So bytes error, let's do, and by the way, JSON marshaling and unmarshaling and Go is horrible. It's absolutely horrible. It's so fucking bad compared to Rust. Rust does this really, 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 really well. And the people who made the, what's the name of that generic library for going back and forth between structured data? It's so good. It's one of Rust's best achievements. I will not even lie. But the rest is horrible. It's just not worth it. So we need to do an e.json here. Saturday. Saturday is brilliant. I actually worked with Saturday and with the people over there. I worked on Tumble a lot, and so I would cross paths with Burnt Sushi every once in a while, who used to be a moderator until he resigned in disgust very publicly because the Go project is so crazy stupid. See that? It worked that time, right? The problem with that, though, is that if somebody tries to marshal my data in any other place, they're not going to get the data that I want. They're going to be forced to use the escape data. So I am not done with this yet. So if you want a generic solution for a struct, for any struct, you should do this. Yeah, but the problem with this is that then you can't force it to be unmarshaled properly. Doing string replacement in a second pass is an inefficient and cumbersome workaround. Yeah. Thank you for the detail. This is very surprising. I ran into this when getting surprise errors and marshaling it to JSONB for Postgres. Yep. The final surprise, though it's not documented, is that encode adds a freaking new line to the end. So the completed normalization part, you might consider streams trim. Yeah, you're going to do an entire fucking trim? No. Just chop the last one off. You know how hard it is to do it? No. The equivalent trims for the new line are bytes, trim byte, buffer. No. Don't do this shit. God damn, people are stupid on Stack Exchange. That is horrible. You could just like truncate the last letter off because it's guaranteed to always be there. Oh my God, that's so bad. And okay, and that's like so much extra effort just to do that. And in Go 1.7, you have added the new option, encode JSON, set escape HTML encoder. Well, yeah, but you have to set up your own JSON encoder. JSON new encoder, blah, blah, blah. This is totally stupid. Okay. Anyway, doesn't answer the question directly. If you're looking for a way to how to deal with JSON.Marshall escaping, another way to solve the problem is to replace the second escape character and JSON raw message into your valid blah after the JSON Martian call. So wait a second. This person is suggesting that you redo your entire string by parsing the whole thing again and fixing the problem that JSON Marshall did. What a great solution. Oh my God. Do you see this? How on earth are people suggesting that? How stupid do you have to be to suggest that? Oh my God. Okay. So Marshall interface. Here's my workaround. Marshall. So again, people are making all these wonderful things that are not being observed by anything that uses a Marshall JSON interface, which is a lot of things. So set HTML false. I mean, this is what I did. So that's fine. That's good and dandy. Third-party package now, rather than standard lib for JSON. Yeah. At first I was having significant difficulty on marshaling XML. Yeah, I'm just. I mean, thank God we just use the string stuff, right? So encode JSON. Boy, I'm so glad. I feel so validated because I made an entire library just for this shit. I did. Let me show you. Clone JSON. And this will turn anything into JSON. Anything. Any object whatsoever. It will turn it into JSON. And all you have to do is kind of a pseudocast as JSON. It's the as JSON interface if you're implementing that. You know, and so yeah, Marshall, it makes a new, so this is the one that Marshall, JSON.Marshall. It gives you your new encoder, says escape to false and does the encoding right. Although it's doing a trim space because I'm an idiot, I need to fix that. I need to look an issue on this. Replace trim right with len buff -1. Submit. All right. I might have to take a break here. This is more effort than I anticipated, but it's working and it's worth it. Anyway, so we've got our JSON marshaling working now, and stuff. All right, so let's actually do the prompting thing. It's been about an hour, so I'm gonna stand up and walk around. I'm gonna take a break. YouTube, you won't see the break, but the rest of you will. All right, so we're back and we're going at it now. So the first thing we need to do now is just print. So we're going to change from printing logging to printing actual stuff with printf. And we're going to grab the I. We want the I now because the I is a number, right? So we're going to do that, and then we're going to take the V and pass those in, and we're just going to copy the other one here. So we'll just do, I mean, we can just do V here and then a dot. And a space. We're not going to do any kind of like, cleanup, and just a V and then a line return. So that we'll get it. Now we still need to, REPL until we have a choice. So we need to loop and get that. So, but we can probably go ahead and build this now. And okay, so it's printing it out and it's printing it as JSON. Now, I don't know if we necessarily want it as JSON though, right? So, in this case, we are just generically making it any kind of thing. So let's go back and make it something that's more reasonable. Let's just make it a string. We did the entry choices because we wanted to have some fun with that. But let's just do the string choices. And that'll give us the first check and center trace. No, we got a problem. It's a 0. So let's go fix that. Let's increment this I by 1. So that'll fix that. 1, 2, 3, 4. And now we need our prompt. So we're not like paging or anything. We could, but that's something we'll add later. So we need to wait around for a prompt. So the first thing is, let's actually print something. Let's say, well, let's look at the select statement, right? So z edit, peg in or something, So it just puts the number and then a question mark. So again, we're just trying to recreate that functionality. So we're just going to say, and let's make this a variable. So we could say it's for the entire package, right? We could make it so that it has a prompt here, you know. So let's do that. Let's do two things. Let's make the prompt default prompt equal this. And we'll go ahead and do that. And I'm making a YouTube video about Go programming right now. Magic. Try learn might get you some stuff. So let's go here, and now what do we need to do? We need to go print that. So fmt print without the ln, and we'll print the default prompt. Now, if we wanted to, we could actually take an option here, right? And so yeah. I'm going to show you a trick that we can do here with a cast. It's like a pseudo cast. And it's kind of my trick. I've never seen anybody use it in the wild, but I really like using it for providing extra methods to things that don't actually exist. So I'm going to get there in just a second. So there, we got our thing. Now it's not waiting around, right? So for that, we need to get something. And I'm going to cheat because I've already written this code. I use it all the time, and I want a prompt that I have tons of prompts. This is all my term package, rwxrob/term. You can use it, you can do whatever, but it's super important that you consider what it contains, because it's, it's prompting for hidden input. There's actually probably a better way to do this that uses the believe it or not, the crypto SSH library. That this is using a standard input syscall. No, terminal read password. This right here, this read password thing, that comes from a supported library, and so it's guaranteed to be the best possible option for reading hidden stuff, no matter what operating system you're on. But we're not reading hidden. I just want to make you aware of it. So we are checking to see if we're interactive here. And if we are interactive, we're going to print out the prompt, and we're going to send some things here. Now we're assuming in this choose thing that you are interactive. If you're not interactive, we're not going to give you anything. Now, another way to do this would be to make the program so that either it's interactive or not. And if it's not interactive, then you allow it to read from standard input, which means that you're like filtering it in, you're piping it in, you're not waiting around for it to have something entered. And that's probably the best way to do this, so that people could use your little tool to, as a proper Unix filter or something inside of some other program, instead of blocking on interactivity, which you never want to do in any kind of program unless you're really sure you got a terminal user interface. But in this case, we're going to print out the thing, and then we're just going to read one line of text. Now, I've written this all up as well. And so to read, this is the standard way to read. You make a new scanner and you scan once, and then that will read a single line of text up to the first control line, character line return. That's what this is. This is the standard way to do this, right? It's absolutely by far the standard way to do it. So I'm actually going to steal this function from here. I'm going to put it in my program. And I don't know if I want to make it public or not. So let's actually just make it private. We'll just make it private. Read line. It's not really read line, but let's just put read. And we'll just leave that there. And so we can say this. We can say, response equals read line, right? And then we need, if the number, it's going to be a number, right? So then we need to convert it into a number. So we could say, let's say like n. We'll say like n is the index. So n equals int. Wait, sorry. String conv dot I to A, which is from C, response. And that will like grab the spaces off the end and everything. And I think this returns what is, oh, is it string convert? No, it's strconv. Why isn't it doing it? Why isn't it doing it? It's strconv. There we go. Now it'll do it. I should do it anyway. There we go. So, привет. Let's say so format in is equivalent to blah, returns the thing in 64. All right. So, and so no matter what, that's going to give us an n. I think the n will be like some number or something. What does it say? Is equivalent to format int. All right. Well, let's format with format. Let's try it. Format int. Format int returns a string representation of I in the base. Blah blah blah. The result is lowercase letters. Oh geez. I think it would be 0 if it doesn't get anything. I don't know though. I kind of want to know that. A to I. I mean, if it's 0, I need to know this. I'm going to test this right now. I need to test this. It's driving me crazy. So this is my test code here that I just have up to test new things and go try it out. It's always the best way to learn how something works. So string conv dot I to A of an empty string. I have to know what that is. Go run untyped string constant as int value and argument to blah blah blah. What? Oh, A to I, duh. 0. Huh. But it didn't throw an error. Very interesting. Did you see this? Look at this. This printf interesting. Assignment mismatch returns 2 values. Does A to I return 2 values? No, it does not. Does it really? It does. It does return 2 values. Aha. Uh-huh. Ah. Indicarbon I use. Fine. Parsing. Well, invalid syntax. So it does return an error. Okay, well, I had it wrong then. So let's say error here. If it returns error, return nil an error. Either that or it's like, I didn't know what you wanted. So actually to do loop until we get a valid integer. So that's what we really want to do, right? That's what we really want to do. Indicarbon I use. All right. And then return empty. So we actually don't want to do. We want to look it up. So another thing we need to do. Yeah. I'm going to just do it right now. I'm going to do it right now. For, we're going to do an infinite loop here. Never, ever, ever come out of this loop. For what? for var n int, for n is for n for not n is greater than 0. Keep looping. Yep. We don't even can ignore the error. We don't even need it. Yep. And then another thing too is like so we could say if we need to check whether we have one, right? So we need the choices. If choices, wait, if v comma okay or have choices n, if not have continue. I mean, there's a million ways we could do this. So then we just need to do this prompty stuff every time. So let's do that. And we can put all that into a function if we wanted, but if we have choices... Oh, wait. If we have it, then actually we can just return... we can return the value and then a nil. What are you doing?
Serotonin boost to your followers.
Why are you doing that? We're in the middle of a YouTube video. It looks really funny though.
A dachshund eating a carrot with antlers.
A dog eating a carrot with antlers. Why would a dog eat a carrot anyway? I guess they like them. So if we have choices, if I do have one, then I want to return it with no error. And down here we don't really have a thing. We're never going to get there. For this one we just say for n equals 0. So we want to loop until n equals 0. I mean, there's a million ways to do this. I don't really care which way we do it. I mean, let's see, default prompt, read line, n equals string converge. So that's going to be 0. It's going to keep being 0. I mean, I guess we could do this instead. We could return this and say break. Let's do that. I mean, it's kind of stupid to do that, but actually, no. If this is, you know what we could do? We could just say n equals 0, and then it would just keep our loop going. You know what? Screw it. This is just going to be a regular good old break. It is. It's going to be a good old break. I don't even need the n here. I like this better. So n, blah blah blah. If we have an n, if we have an n, then break. Otherwise, loop forever. Loop forever. That's much better. Control C is not a case. That's an interrupt, and we have to trap that separately. Control C is if we did a Control C, we're just gonna watch. I'll show you. Yeah, we're gonna. Well, we don't need that anymore. Wait, where are we? What the hell? I'm in the wrong thing. I'm not supposed to be in there. It's supposed to be in 2. 2 is going to need to reload. Yep. That was bad. Okay, so this is where we need our build. I'm kind of all over the place. Oh, we can close this one. I'm a spaz. Let's do the choice install. All right, so empty declared but not used. Var empty. That's only if we have an error. So there is no situation where we have an empty now. So we got this code will not ever exit until you have a thing. 27. If we have a choices, What? Two variables with one value. Oh, it's not a map, of course. It's not a map, of course. I feel silly. If n is less than it's never going to be greater than 0. I mean lower than 0. So if it's less than len choices, then do this, then break. That's all. That's all. Undefined v. Return choices v. Yep. First choice, undefined v. Bullshit. How about choice? Oh, I need an n up here. Fine. Var n int. I guess I did need it after all. Yeah. There we go. First choice. Well, that failed. Oh. If it is greater than... Well, no, because 0 is an option, actually. So we do need to check the error. Interesting. Yeah. Because now I have to trap the error. That's going to be hard because I can't get the n as well. No, we can just... I don't even need to fucking break. I don't need this either. I don't know why I didn't think about this earlier, because I'm dumb. If not error, and n is less than choices, return choices n. No. Otherwise, we don't get anything. Invalid operation function variable type t. I feel kind of stupid for doing that. I am also somewhat dizzy, and I don't know why. It's from Twitch streaming, I tell you, I swear to God. Hey, it works. Fourth choice. Uh-oh. N minus 1. Is less than length of the choices plus 1. Actually, n has to be at least 1, right? You know, if we did that, we can get rid of the error. We don't need it. Yeah, so we could say... I like to do this, by the way. 0. So if n is greater than 0... and... No, yeah. And n is... I like to write it like this because it's like that other interval notation kind of thing, right? Is length is less than the length of choices plus 1, then choices minus 1. That works. 0. How about 10? How about 20.3? How about 2.4? No. How about 1? How about 4? How about 3? Got that. So it looks like it's working to me. How about 1.0? How about blah, blah, blah? How about 1? How about 1.0? How about 1 point? How about 1? First choice. Yay! All right, so our program is done now. And it wasn't too bad. I mean, we went about it a roundabout way. Because why? We went about this a roundabout way because we did... 1, we did generics. 2, we did... we did the we did this really fun thing where we have like any kind of choice. Let's actually try it. Let's try it with our entry choices and see what happens. Now, obviously, you could clean these up, right? You could clean these up if you didn't want them, but generically, we can just do it like this. And, 2 will be Doris. You can, that's just because I made the stringer interface into JSON. I could make the stringer interface, better than that if I wanted to. I could use a template of something and it would still give me the same thing. But the whole point of that was to show that you can do this with any type of thing. Unlike Bash. Bash would only be a string, of course, and you would lose its type. So I think the thing that's super important to realize is that when I call this, it's printing the pic, right? But I can use the pic. So like if I was using integers, I could say if it equals above 10 or something, I could actually use it. I mean, in this particular case, I could do this. I could do pic.name, right? So I could do that. Let's try that. So if I do 2, 3, it'd give me Max. If I do this, I say 2, and it gives me Doris, right? And so you can use any kind of structure, and this is one of the reasons to choose a programming language like Go over Bash for this kind of stuff, because you may want to do more with what you're selecting. Now, we could do one more thing that would be super cool. What if we allowed, I'm doing everything as package globals right now, which, you might want to encapsulate all of this stuff into, a chooser, we'll say, right? You could make this into a chooser, and then the chooser would have stuff, and then you would set a default chooser. Why don't we do that? So we do that. And then it would have state instead of having a default prompt for all things in the entire package, right? We can still do this, but like, let's say if you want to be a little bit more object-oriented about it, you could just say, and this is very common Go idiom, is to have, a proper structure and then build in a default instance of that structure so people can just use it if they want to. And Go install just puts it in your Go bin directory. That's it. And it's much easier to use if you don't have any conflicts. So let's do that. So let's do this. Let's give this, we'll call it a chooser. So this would be choose.chooser, right? Now, normally chooser, that kind of name would be reserved for an interface, right? And quite frankly, we could make an interface here. We could say anything that implements chooser. You want to do that? There's so many things we could do here. So we could say, so we do a proper interface. Let's do that. So type chooser is an interface. So a chooser is anything that has a choose method. All right. And it takes in, choose takes in actually, I don't even think we need that. No, we do. We need that. I haven't done an interface with generics in a while, so this would be interesting. So choosing a T, choices of T, and I get back a T or a potential error. All right. So now I have, we've been doing generics. So now I have a chooser. Now I'm pretty sure I have to put T here. I think I haven't done interfaces. I don't, I'm going to get in trouble here. I don't know how to define an interface for, I don't know how to do this. I don't know how to do an interface. I haven't done one. I don't know how to do a generic interface. I know how to do interfaces, but just not a generic interface. So I have to refresh my memory. As just interface. Well, that was another trick I was going to show you, but I don't want to. That'll confuse you if I show you that trick too early. It's a way to turn, if you want to give something a bunch of methods, you can kind of give something methods by wrapping it in a structure that has those methods. Yeah, it's a super cool trick. I'll do another video on that. I am really dizzy. I wonder if it's the air in here or something. Anyway, you can use constraints. Yeah, I don't know. Ba 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 doo boo boo ba doo boo boo. I'm missing something here. I'm trying to figure out what I'm missing. Coffee? You think it's coffee? No, I think it might be the coffee that's making me dizzy. I had a lot of coffee. That might be it. Oh, I have too many of these. Dummy. Dummy. All right, let me try the generic again. T. Choose T. Choice any T. T. I think I can do this. Oh, yay. It worketh. That worked. And I don't think I need a T here. I don't think I need that there. No. All right. All right. We did it right. Oh, wow. Okay. So it goes on the interface. All right. I needed a reminder. So if I want to make a chooser, okay, so now let's implement a chooser. So to do this, we are going to make an internal private struct that implements this, right? We're going to call it chooser, and we can use the same case, just lowercase. I know this is a thing. It's kind of weird, but you can do this. Okay, and now we need to make sure that they can get one of them, right? So we can say, so let's be choose dot whatever, right? So let's make a constructor for it so they can get one. We don't want them instantiating this private thing ever by itself. So we're going to make one. So we're going to say func new chooser, choose new chooser. And the chooser is going to give us, a default chooser, right? So this is going to be used our chooser, right? And we're going to implement this chooser as our default. Another way would be to actually define the chooser as, and like do a single struct instance of it. So that might be the way to go. Let's do that. So let's say var default chooser, right? And the default chooser will be a new chooser. So we're going to make an instance of this chooser, and that's going to be our default. And this chooser is going to implement the struct. So we're going to do a trick to make sure that our chooser actually implements the interface properly. So this is a trick you can do. We're going to say var nothing, which is a chooser, equals, and we're going to force it to be a nil, but we're going to say that it needs to be an instance of chooser. Right? So an instance of chooser, we're going to make a chooser, and we're going to put this is a really interesting trick that you can do. So this, I can't quite explain everything it does. It takes the nil value in Go actually has a type, and so by coercing nil into a type and then assigning it to a non-existent variable, and that is of type chooser of the interface, it forces the compiler to do all the checking. So this is not a runtime thing. The overhead of this at runtime is like super duper negligible. At runtime, if you wanted to put that in right before your final build, you could, but this actually checks to make sure that you're fulfilling chooser without having to call it. So then you can do stuff like, just a basic Go test in here. wait, let's get rid of that one. Where are we? 3. So if we just did go test, we get undeclared name T from array undefined T, choose 19. Cannot use C of type chooser is of as type chooser in variable declaration. Variable of type chooser as type cannot use chooser nil. Did I get it wrong? No, I don't. I think it's right. I think it's right. It's because I didn't have a T, I think. Yeah. So I think we need to do this. I think we need to do chooser. This is going to be interesting. I've never used this trick with an interface implementation. No, I haven't. So this would be interesting. So type chooser. So we're going to have to give chooser an interface. It's going to have to be generic. This is super interesting to me. Yeah, because I don't do a lot with generic. So, and I do think that we're going to need to put a T here too. Yeah. Wow, this is cool. Undeclared name T for length array 18 and 19. All right, so we're kind of pushing the streams here. Chooser. I think I have to put any here to force it to be a type. Undeclared name T for array length. Type. I don't know where that goes though. This does not go there. I don't know. We're gonna see here. That was weird. I don't know what's going on here. I'm like out of my league on the generic stuff. Cannot use generic chooser type without instantiation. Good, that's a good error. We want that kind of error. That means that, oh, right. So we need a new chooser type any. Yeah. Yes. There we go. All right. We're back. We're back in action.
Bye.
Bye.
Love you.
See you. All right. So we got our chooser there, and we've got our interface implementation, and our chooser is not an implementation, but it didn't catch it. So my little trick didn't work with generics. That's a discovery, my friends. That is a discovery. That little trick for checking your variable definitions, for checking your interface. Cannot use generic type chooser. There we go. Oh, wait. It is broken. 26. Cannot use generic type T chooser without instantiation. Aha. Oh, so we can't force it. Can I use a T here? Oh my God. We can't use the trick with generics. We can't use the interface check trick with generics. This is interesting. This is extremely interesting. I thought for sure you were going to get no, we can't. Because you'd have to, so the only way to do this would be to actually instantiate one. So generics is, this is a discovery, and I'm going to put this in my Zet really quick. Generics in Go block interface validation trick. I bet they didn't know they were going to break that. I bet they didn't. I did not know that. Yeah. I'm just gonna. I'll come back to that later. I just want to put that note in there so I can write about that later. That's super cool. So much for that trick. So we're gonna have to do the old-fashioned way, which is a little bit harder. Why are you not? Why you no edit? All right. So now. All right. So that, okay, but now we need to implement our chooser, right? So we need to implement it. So let's do that. Let's do. Let's go implement. I'm gonna change all my Z stuff, by the way. I just got the keg stuff done, so I'm using integers now. So it should be a lot better now. Anyway, so let's go back. So we have a chooser. So, I mean, let's change this stuff to use our new thing, right? So let's say we don't want this from. We want all this code, but we don't want this code to be hard coded into this package. We don't want this package, right? Maybe we want the from, but we want it. We want to change it, right? So, I mean, we're going to need that code. So let's comment it out. We're going to need that code for sure. But the from is going to get a lot easier. Your choices using the default chooser. All right. So now we can do all of this stuff. We can get rid of all of this. And we can just return this. We can say return default chooser dot from, right? And so we can do our delegation, and then we just pass in choices, right? And that's it. And I could do def chooser, let's do default chooser. How many? We got 72. I don't go over 72, so I just don't. It's just my thing. All right, so that's what we want to work, right? We want to save all of this other work, and we want to make from into a method. Well, how do you make a method on a struct? So actually a chooser needs to have a from, we'll say. No, it needs to choose. It needs to choose. Let's change it from. Let's change it to choose. Because we still want, choose dot. It only works because of the package name, but we really want it to be choose. So we're going to make it choose, right? And choose is all the same. And now we're going to hang it off of here. Now, the way to do that is to give it a receiver. So we're going to give it a receiver. We need a chooser. We need an instance of chooser. And we're going to be, we're not going to be changing any of the values. So we don't need a pointer. And we're going to say, I need a chooser, right? So now choose is a method. And here's the other thing. We don't need to get choices anymore because, we could instantiate a new chooser and then give it the choices, right? Or we could make it so that it takes the choices. Or we could put all the choices into a slice, or we could do the casting and give it a method. There's like so many things. Yeah, you could do our chooser. So if we were to do choose this way, it's like, what would really be great though is if we made our type. What if we made our type? What if we made our type implied, so that it's like it picks from itself, right? Yeah, and then we can do that. I mean, I'm just having some fun here, but so I'm gonna change this idea of a new chooser, and I'm gonna use my trick. Yeah, I'm gonna use my trick. I'm gonna use my trick here. So the type here is really not. We really don't want a struct type. We want to put this as a method on any slice, right? So watch, and then I'm gonna be able to cast it, right? So if I do that, then I can say this. I can say choose. We can say that the chooser is. We could say that type choosable. All or something. A choose or choices about that type choices. So choose that choices. A type choices is a slice of any. It's a slice of any, right? Actually, I could make it a slice of any. So if it's a slice of any, then I can act because it's a type now. People don't know this, but you can hang methods off any type, string, struct, anything, right? And that's one of the greatest advantages of Go. So we still can have our chooser interface, um, or choosable or something. A chooser dot a choice a choose dot um, set choose dot choices. How about that? Choices. I mean, I kind of want it to be nice. We already have choices. Uh, it has a chooser. I guess we'll put a chooser. I don't know. It's not really a reader or writer or anything though. So, and anyway, so now we have this. So we have chooser. We could have c dot choices, right? And we're not going to be changing it again. So we're going to do that. So prompts terminal to click user from pick one of the choices, right? But we got rid of this thing because there's no. It is the thing, right? So the range choices. So instead of range choices, we do range C, and we set up the default prompt and all that. All the rest is the same. This is now C instead of choices. C. So now we have a choices, right? So what we can do is cast something to be a choices. And I'm kind of cheating here, but so from choices T, default chooser from choices. So what we could do in this case is we could actually from this one, we can actually cast choices. We should be able to do a chooser choices dot choose. And yeah, chooser choices choose. So we're going to do a cast. And that should work. So I'm doing a lot of stuff all at once, which is really bad. But I kind of going fast here. What do we got here? 17. T interface any. I think I did the interface wrong on this. Yeah, we might this whole generic stuff might get in our way, but I'm actually glad we're doing it that way because it's forcing me to do this properly. 20 and 24. I don't know if this is the thing that's triggering it though. Oh wait. Twist T any. I think that we need a generic reference in here as well. Yeah, but I don't. It's been a long time since I did generic, so 24. Range choices. Was it saying expected semicolon? Oh, did I? What have I done here, my friends? What have I broken? Something is broken. Something obvious is broken. All right, so chooser T. That's not it. Let's see what I broke. I should have checked out some stuff more quickly. 24. Method must have no type arguments. No type arguments. Huh. Oh, that's surprising. The T's being pulled in from here. I think I have to put choices T here, actually. I do, but I don't know that for sure. Oh, you know what? It's because, you know what it is? It's because my choices, I didn't make choices a generic. No. I need to make T any t. I think. Let me check. Yep. So that's going to give me an error, I promise, because it's going to say, yeah, cannot use generic type t any without choices line 27. See, now it's saying you can't use it without instantiation. And that's what I had before. So we need a choice type T here. I'm not sure if it goes there or here. I think it might actually go here instead. The type definition is that's just for the chooser interface. That's not that we don't need that yet. That we will add that back, I promise. But this guy, all parameters must be named. 27. So this has to be a T as well, I'm pretty sure. I can't remember though. I forgot how to do this. 27, all type parameters must be named. All type parameters must be named. I don't think I need it there. I think it needs to be... Yeah, it needs to be here. Yeah, I got it. Yeah, that's different. This says... Yeah. All right, so... Yeah, goddamn. Okay, I mean, I didn't mean to complicate this with generics, but it's good for me. Undefined chooser. Okay, so now we need to define that we have a chooser. Return, we need to turn it into a not a chooser, but a choices. And then we're going to do the interface check. We're kind of ignoring the interface for right now. I promise you, we will get there. So cannot use generic type choices without instantiation. Okay, I thought so. So we want a choices any. No, we want a choices T. I thought we could get away with that. 44. Yeah. That should be. Oopsie. There we go. Oh boy, it worked. Oh my god. Oh my god, it's working. Why do you sound so surprised? This generic stuff's probably like lost a bunch of people, but a few of you might have appreciated it. So what did we do? We turned any slice into a castable choices object, and by doing so, gave it a method called choose. So that means by doing this, you can turn any slice at all of anything into a chooser. If you're interested in the Zettelkasten stuff, please follow Keg, because Keg and Zet are going together. And I just finished the first specification of Keg, so make sure you don't, because my whole Zettelkasten is going to change. Yeah, it's going to become a Keg, and that's very soon on the horizon. Let's try the interface. So let's see if my interface is actually going to work. So choices is a chooser, right? The truth is we're not going to be able to test this because we're not using it as a chooser. I don't know if maybe that might be overkill. Yeah, I don't know. We're going to try this. Oh my god. Oh my god, it worked. It hasn't worked yet. Give me a second. All right, so all right, now in order for us to choose that, in order for us to watch, we gotta check it another way. Yeah, see how it says choose from entry choices, right? Let's do this a little differently. Let's comment that out. Let's say I want to turn this slice into a chooser. Well, I mean, there's a number of things that we could do here, right? I mean, you already saw it. I could do it in the other one. If I wanted to, I could do this. I could say, choose dot choices as a cast. It looks like a call. It's not. It's a cast. And then I can say choose. Choose choices, entry choices, choose. Choo choo. It had to be said. Cannot use generic type. Choose choices and instantiation. So because we made it a generic, damn. I was afraid. I was hoping it would pick it up. Nope. No no such luck. So we have to do that. It's an entry of type entry. It's much shorter this other way. I mean, it was a fun experiment. So now we have like through. It's working, right? This choose that from is shorthand for what we just did, right? The point I'm trying to make is that you can cast it if you want. So any slice could be used that way, but it's probably the easier way to go about it. Obviously, I want to use this one. It's much easier, and that'll get us what we want. But again, we should be able to pick anything. Let's go back. Let's try our strings again. String choices. Let's try that. Whoopsie daisy. God damn it. Oh, because that's my bad. Of course it's my bad. It's only my bad. I'm the only one doing things, so they're all my bad. All right, so let's load. Yes, okay. I don't want to pick it. I just want to pick it. FMT println the actual pick, right? It was a string before. That's why that did that. What the hell? Why is it doing that? I know why. Because I'm a spaz. I am a spaz. I am a spaz. Okay, so let's go. Here we go. Choose. Third, fourth choice. 3. Third choice. Okay, so it's still working. The code is working. There you go. I am going to commit this right now. That'll be our final act of the day. So git add -a dot. And we can just put quick and dirty replacement for bash select just as an experiment. And you can go watch the YouTube stream. Go watch the YouTube stream. How about that? I mean, I'll put a thing in there eventually. So what even is this video? I don't even know. We don't know yet. All right, so git add. I got to do the whole thing here. Git add dot. That adds it all. Git status. Git commit. Let's say implement simple. So how do you write commit messages? This is how. Answer the question. If I apply this commit, it will implement choose implement from and choices. Is that right? Slice type. No period, no punctuation, under 50 characters. That's why we're doing this. That's a good commit message. Go look it up. All right, so now we just need to get push, and it should be up there. You go find it, refresh, and there it is. So to the chat, you just go to rwxrob/choose, and you can go have fun with that. Hopefully you have a good time with that. Have fun with it, YouTube. See you next time.